Good morning, everybody. Welcome to our EARTO webinar series on standardization in research and technology for practitioner. Today we have a little bit different way to present the topic standardization and open source. Next slide, please. We have with us Mirko Böhm, who is head of the Linux Foundation in Europe. Again, the whole thing is in the context of the EDU4Standards project, and it's on the pilot on focusing on the EARTO community. Plus, meanwhile, hopefully some people also from the Marie Curie program who are meanwhile in the alumni organization. Next slide, please. That means we are here to empower the Europeans in standardization, and therefore it's also very important to consider the interlinkages to open source. The point is that last week we talked about standardization and intellectual property rights, and in the past patents were here in the focus. Meanwhile, also open source is an important interface. Therefore, Mirko Böhm is with us. Next slide, please. That means we are now really at the sophisticated level, because that's still an emerging field, how the standardization and open source might go together, but it might be also the case that there are some conflicts, and therefore this is also a little bit a moving target, with new developments coming up quite often and dynamic, and it's not so established compared to the topic of standard essential patents. Next slide, please. And that's our program. Today we have Mirko Böhm with us, and next week we conclude the series also with the guest speaker. Therefore, when we have two kind of parts. The one is on the geopolitics, and the other one is on ethics and values in standardization with Barbara Reiter, a philosopher from the University of Graz. But now I hand over to you, Mirko. Maybe you have also some words about yourself, Mirko.
Sure. Welcome, everybody. My name is Mirko Böhm. I work for the Linux Foundation, and in recent years, Knut Blind and I have conducted a number of studies on the relationship between open source and standards development. Before we begin, this is going to be a webinar, so I'm going to primarily present. And if you have questions, I would encourage you to use the Q&A functionality of the team session, and Knut will look at the questions and we will discuss them at the end. So please feel free to do that. The agenda that we have today is essentially an introduction of the tension between open source and standards development, a discussion of what open standards are, and then the relationship of free and open source and standards, and some practical implications, where I also added two recent case studies that are indicating kind of where the field is heading. The underlying research here are two publications that basically inform the slide deck that you're going to see. One is a paper by Davis Isaac and me about standard setting organizations and open source communities, partners or competitors. This was published in 2021, and the other one is Knut Blind and my work on the relationship between open source software and standard setting, which was a European Commission project published at the Joint Research Center in 2019. The objective is to understand the difference between standardization and open source, and to understand their interactions, and especially how in the process of researching and inventing new approaches, all the way to those new technologies being widely adopted in the market, these two approaches basically do the same things, and where do they apply different processes, essentially. And based on that, we can compare their strengths and weaknesses and see how they can interact. Before I begin, just to put this into context, we're not talking about a subject here that is historical. Yesterday, I've met the representative of Dean to the Cyber Resilience Act standards development process at Senelec. And he gave me a bit of insight on the tension that we currently see. So for example, the process of developing standards is very much based on in-person interactions at meetings. And the people involved basically say, well, we've always done it like that. And that's true. But it's not how the world collaborates today. Another issue is that the draft documents that the working groups are creating cannot be shared within the organizations that you represent. They're basically only accessible to the people nominated to work in the working groups. Now, this is really not conducive to open collaboration, and kind of rubs the people wrong that we send into these working groups. So what you see from that is that in 2025, we have very concrete issues in the relationship between open source and standards development that are more questions of culture and processes than questions of common goals. So let's see, let's dive into this a little bit. We can begin at a pretty high level and say, what are standards? The reason why we begin this way is to kind of position first standards development and open source development in the same context. Standards are a tool. They're a utilitarian approach to improved overall quality of life by enabling us to adopt technologies at scale, and to basically shape markets, to say competition should be within a market according to a aimed for standard, let's say, instead of competition for creating markets, essentially. At the same time, what we speak of as the wider open source community is a global movement that develops open source software. And open source software is essentially a public good. The basic requirements on for open source licensing, use, study, modify, redistribute, we'll talk about this a bit today, translate to these goods being non-frivolous and non-excludable, meaning they're public goods. And as a result, they're privately owned public goods, but that means that the open source community benefits the society and contributes to the common good in general in a positive way. And based on that, we have a pretty strong interest in both communities essentially working together. And this is where the tension has been in the past. So one of the triggering points for the study that we worked on and published in 2019 was that while everybody agrees that these two ecosystems should collaborate closely, in practice, that wasn't always the case. We went at this and basically said, how can we use a more generic approach to describe the what is essentially a process of promulgating open technologies into the market. And we describe them as standardizing effects. And a standardizing effect is something that takes the need for a standard and translates it to a situation where that technology is adopted in the market to a satisfactory extent. And we realized that both open source software and the collaboration on the development of it and the work of standard setting organizations are causing standardizing effects. They're basically almost like complementary mechanisms to achieve the same utilitarian goal. And because of that, there's the expectation that there's a mutually beneficial collaboration between them that is possible, but we don't really understand why it doesn't happen and how it should work. One thing we did is we developed a phase model for standards development that I will explain in a bit, that is able to explain the processes of open source communities and of standards development in the same model, which I think is a big step forward in that discussion. So before we begin, also a little bit to set the scene, we need to talk about open standards. why is this important? Because it already indicates a little bit the difference in understanding between standards developers and open source communities. When we talk about open source, we say that there are two essential dimensions to it. One is licensing. This is what most people are familiar with. Basically, by applying an open source license to any information good, typically software in our context, you give the user of the software the freedoms to use, study, modify, and redistribute the software. And this is an aspect of access to the technology. It is not a question of how is the technology developed. When standards development organizations speak about openness, they're mostly referring to governance. They're basically saying, who has access to the standards development process? Is this a process where all relevant stakeholders can participate and will be heard? Is it transparent? Is there enough regulatory oversight to make sure this is all pro-competitive, etc.? And these two dimensions, governance and licensing or access to the technology, are recognized both in standards development organizations and in the open source community. And when the open source community says open, it primarily refers to access to technology, basically licensing. When standards developers speak of open, they refer to governance. And this is almost a question of two sides talking at each other, but not to each other, because we're using the same word, open or openness, pretty much in almost opposing contexts. And that doesn't help. That's one of the weaknesses that we're also highlighting at the European Commission in the Regulation 2025 review. So what is an open standard? An open standard is a standard that is openly accessible and usable by anyone. That's the Wikipedia definition. If you look at the definition of ITU, it's a standard that is made available to the general public and developed and maintained in a collaborative and consensus-driven process. So these are the two dimensions: governance, process, and accessibility. Now, if you see the typical IPR regimes applied by standards developers, the question of made available to the general public and usable by anyone is not always fulfilled. As soon as we have standards that are either licensed through copyright on an individual basis or come with standard essential patents, that is not the case. And this has led to recent tensions. If we look at how the open source community thinks about this, the four freedoms that I mentioned, use, study, modify, redistribute, are expected to be in every implementation of technology. And that means that we can only consider a standard open if it allows us, if the IPR regime of how the standard is promulgated allows us to implement the technology in a way that it can be used, studied, modified, and redistributed. So it's basically all about access to technologies. This implies not only a royalty-free licensing scheme, but also an absence of negotiation. What does this mean? In the open source world, all rights to technologies are agreed on when the user begins using the technology. The open source licenses are essentially an offer by the rights holder to say, you can use this technology under these conditions, an open source license. And when the user accepts implicitly by using the software, an agreement comes into place that says, I have these rights given by the author and I respect the obligations from the license. And this all happens in an imagined way before the use of the technology begins. So all rights are secured before the user starts using the technology. Any downstream negotiation, meaning that once a technology is developed and introduced into the market, and then, for example, tracking who uses that technology or negotiating per seat fees or anything like that, is something that doesn't exist in open source. And this is, again, a process question. It's a question of what kind of IPR regimes are suitable for the development of open technologies. We also actively forbid, in a way, in the licenses, any restrictions on redistribution. That means the technology is made available very strictly to anyone for any purpose. There can be no restrictions on commercial use, on open redistribution, on regional distribution, etc. And in the open source community, we always like to apply openness, both to the technology itself and to the process. I've already mentioned FRAND, and this basically is an issue that is completely unresolved from our perspective. In the standards world, FRAND is often communicated as a success model. People point to the very established FRAND approaches in the telecommunications sector. That is all true, but there are two aspects to this that make it questionable how we can adopt this in the future. One is FRAND is only successful in the telecommunications sector, and the telecommunications sector is not the biggest and the only technology in the world. In all other fields, this approach is not successful. The other aspect is it is really unclear what FRAND means. When you ask, what is FRAND? Basically, the real answer is only the people that negotiate the agreements out of court at the end of the technology development process know. Typical FRAND agreements are not published, and there are no standards or some standard requirements, but there are no standards for what FRAND really means. Because of that, there has been a lot of discussion about compatibility between licensing regimes, and I frankly believe that this question cannot be answered, because you cannot answer a question theoretically on the compatibility of licensing regimes if you don't know the licensing regime. And also, and this is actually explicitly reviewed in the 2019 study, you can only analyze this question of compatibility on concrete cases. So for each specific case, you can ask, are the licensing conditions of the underlying open source licenses compatible with the FRAND regime that is applied? You cannot make a generic distinction. Because of that, from an open source perspective, it is not a recommended way to draft future IPR schemes, regimes with the FRAND approach, if you're interested in the adoption of open technologies in that field. So now to the relationship of open source and standards. Again, the motivation, this is by the European Commission, integration between open source projects and standards development processes is a win-win situation. On one side, the alignment of open source and standardization can speed up the standards development process and the take-up of ICT standards. On the other side, standards can improve for interoperability of open source software implementations. This is published in 2019, and this was one of the triggers for the study that Knut Blind and I worked on. But we are immediately entering into a problem here, and that is, from our perspective, an antiquated view of what a standard is. We basically have a standard for what a standard is, saying a standard is a document established by consensus and approved by a recognized body that provides guidelines for, and etc., aimed at the achievement of an optimum degree of order in a given context. This is the ISO/IEC guide to standards development. Basically, what this says is, a standard is what a standard setting organization produces. There's no way around this. It is a document first. Now, this could be an electronic document or even a machine readable document today, but it is by definition a specification of the technology. And it's established by consensus, meaning an open stakeholder process, and approved by a recognized body. Now, the question immediately is who's recognizing who? Yeah, so this is basically the view of standard. And quite frankly, I believe this is a short-falling definition. Why? Because we can empirically observe that the definition of standards as they're adopted in the market is not restricted to the documents established by consensus and approved by a recognized body. That means if we apply this definition, which is very popular and very widely used, then we only explain those aspects of the market that are successfully influenced by formal standards development. And I would wager that this is a minority of technologies overall. It also does not explain how open source communities work or include their work in the idea of standards development. So to counter that, the phase model that we developed aims at basically saying we need to have one theoretical model for the promulgation of technologies into the market that explains well both what open source organizations do or communities do and what standards development organizations do. And this is the standardization process. And this process always begins with a need for standardization. Now, there are two sources for such needs. One is a pull by the market. This is if market actors, industry players, and consumers by themselves feel the need for standards development. This is commonly the case if there's a need for mass production, for interoperability between devices, or simply for complementary products where one manufacturer creates computer screens and the other one creates computers and they need to work together. There's a market pull for that, and I think this is a very powerful force, basically. There's also a regulatory push from the top. Basically, this is what we think of in terms of security standards, operational security standards sometimes, or consumer safety. But in the end, whether or not the need for standardization originates from a market pull or a regulatory push, the situation is, as a starting point, is relatively similar. It is, we need to develop a technology that is then widely adopted in the market to fulfill that need. At the end of the process stands a standard that is widely adopted in the market. And by standard, we basically mean technology in this case, because this is a utilitarian approach where we say our need for standards development is fulfilled when an according technology is widely adopted in the market. It is not a document. The document is a means to an end, basically the description of the technology we're talking about. And this is what we describe as the standardization process, and how we get away from the concept that this is first and foremost a document, which clearly it isn't. When we break down this process, we basically have 4 phases in this process. First is ideation. Clearly, first we need to identify the technology that we would like to adopt. And with this idea, we need to have 2 tasks. We need to perform 2 tasks. One is to specify it. That means to describe it in an operationalized way so that we can A, implement it, and B, we can certify in a way that the implementation is according to the specification. So that's why we have these 2 steps, specification and implementation. Now, both are necessary, because only if we have an implementation of a technology, we can diffuse it in the market, and only if there's a specification, we can claim or certify that this implementation actually is according to the technical needs that we have specified. In any case, the process concludes with diffusion in the market. In the case of a successful technology, it is widely adopted, and the need for standardization is fulfilled. Now, if we look at the traditional standards development process that exists for more than 100 years now, the flow of phases, the process overall, has a certain order. So first you come up with the idea, then you specify it, then you publish the specification, and implementers go and create standards conformant products. And those are then introduced into the market, and in the market there's competition for essentially market share to get, this is how the standard is adopted in the market. Here, basically, there's nothing new. This is the work of standards development organizations as we've seen it for a long time. Now, surprisingly, if we look at how open source communities work, they are going through exactly the same phases, but the order is reversed. Ideation, of course, comes first, but then first comes implementation. The way open source technologies are developed is typically in a early release often process, in rapid prototyping, trial and error. It's kind of very competitive in a way, because especially when a new technology, you think of blockchain or now AI, becomes very popular, many projects emerge. There's a race to be one of the most popular projects. And very quickly, the number of projects reduces until one or a few emerge as viable implementations. These are being more or less automatically adopted by early adopters that provide feedback and test the technology. And if specifications are necessary, they're going to be created once the technical requirements and the implementation approaches have crystallized. So implementation comes first, and then specifications emerge, and the technologies diffuse into the market. So if you compare the approaches between standards development organizations and the open source community, the main difference is the order of the two phases, specification and implementation. The problems that they're solving, the needs that they're fulfilling, are very comparable. I think this is the main advantage of the model that we're proposing here, is to say we can explain the work of these two ecosystems with a coherent model that applies to both. Now, interestingly, if you look at reality, then you realize that this has been adopted for quite some time now. There are numerous standards development processes today that have an iterative approach towards implementation, where it is actually not quite clear anymore what comes first, standardization or specification or implementation. The reason for that is that the specification cycles have shortened dramatically. We can see this very well, for example, in the development of programming languages, where the cycles have kind of normalized to 6 months. And in that cycle, we have both an update to the specifications and, kind of as proof points, implementations that demonstrate new language features before the new language functions or features are adopted in the specification. So iterative approaches are becoming more popular, and we believe that this is already a reaction of like the standards development ecosystem and the open source community to this environment where these two camps are essentially offering different approaches to solve the same problem. One reason for why this is relevant now is the two main global trends of digitalization and globalization. Digitalization means, in our context here, that pretty much everything that we can represent as digital information will be represented as such and shared on the internet. And that, for the most part, most important here, drives drastically improved methods of collaboration. And when I gave the example earlier that standards working groups still expect the work to be done physically in working group meetings, this is essentially the tension we're talking about here. Modern methods of collaboration have, for a very large extent, actually been inspired by the open source community. If you think of online issue trackers or your modern Kanban boards, if you think of wikis and continuous integration, all these are tools that originate from the open source community. So the change that this induces is massive. Instead of needing to copy a document and sharing it via mail and waiting for people to send their redlined versions back, and then a secretariat integrating all the changes into a new version of the standard 6 months later, we can do this all instantly online. And naturally, that means there's an expectation towards more accessibility of the development process, towards more openness, more transparency. So these two things go hand in hand. At the same time, we see a shift of relevance from national actors to supranational international collaboration. I think this is very clearly visible in the standards development world. The national standards bodies are struggling for relevance in an environment where standards are primarily developed regionally and globally. Regionally meaning EU-wide, United States, China, and globally, ideally, one standard for all from the start. We also have a shift of the state in the role from an employer to a regulator. We see this a lot in the EU, where instead of producing solutions like rail, the state basically says how the markets should work. And this plays very well into this new environment of competing processes and open technologies. These two global shifts, digitization and globalization, influence essentially the efficacy of collaboration methods overall of processes that we applied. And in this environment, the open source community and standards development have different strengths and weaknesses. The strengths of the open source community are essentially a very chaotic and fast-moving innovation process. So rapid prototyping, release early, release often, voluntary participation in the implementation. There's sometimes an argument where standards developers say, we are also working based on voluntary participation, but the focus in the open source community is on contribution to the implementation, and this is really different. And an often overlooked aspect is the upstream-downstream model, which is essentially how the numerous open source communities in the world collaborate, because they're all making building blocks to an ecosystem that only is useful if you combine all of them together and they work together. Now, interestingly, there is neither an ex ante specification process for how an open source like a Linux distribution should work, nor is there like an overarching coordination body. This is all happening organically, and so it's a mystery and a surprise that it works, but it works really well. There are naturally also weaknesses to such a process. For example, if you have chaotic and decentralized development, supply chain management is going to be an issue. License compliance is complex because many of the building blocks are using different, all open source licenses, all with the same basic requirements, but they're not all written in the same way. And you're comparing a large number of components, you're combining them together into products, and that creates friction, basically. And there's a limited understanding of meritocracy. What this means is that the open source community essentially understands merit as contributing to the ecosystem, and contribution here is mostly understood as code contributions or contributions to the actual product. This is a bit in contrast to the open stakeholder processes that you would see in standards development. For example, it is not natural to the open source community to involve a civil society representative or an environmental group. These are not contributors to the process. If you look at standards development organizations, the strengths are clearly the proven processes, the well accepted and defined IPR policies, and reach an impact because you have, for example, a contract with the German state. If you're dean, you're able to influence both regulatory processes and whole industry sectors. This is not something that the open source community historically is strong at. There are weaknesses, and I think the experience that my friend that is now working at Sensenelec or participating there has highlighted, underlined that a little bit. There's a certain standards development habitus. For example, we will work in an in-person meeting and everything. If you're not attending the meeting, then your proposal will simply be discarded because you were not able to defend it. Sometimes IPR policies are ambiguous. I've mentioned this already when I spoke about FRAND. Processes are cumbersome and business models are outdated. And I didn't speak about this much so far. Selling access to standards in a world that is increasingly expecting transparency and openness is not something that goes down very well. And I think this is really under stress, this idea. And that means that the business model of those standards development organizations that are essentially printing houses combined with working groups, well, that's not. I don't think that's a model that is like useful very long into the future. There are also disadvantages of the whole setup. For example, where neither standards development or the open source community work well on their own, they cannot complement each other. And we see this, for example, in very investment-heavy research and development. And this is one reason why we believe that the standardization patent and FRAND discussion doesn't come to a good conclusion. Because while we say that this is not a model that can be easily translated to other industry sectors, we also don't really have a very good answer to how do you marshal resources like those that were necessary to develop telecommunication standards at this scale if such a model doesn't exist? So they're open questions, essentially, that we don't have good answers for. There's a certain tension between globalization and vested interests. Now, when we wrote this was before the second Trump term. So this was essentially kind of looking into the future and saying globalization always brings tension. Today, this is much more tangible. We have an ongoing trade war. We have tariffs everywhere. So vested interests are very strong, and the open source community as a potential counterweight cannot really influence politics very much. And IPR regimes are still complex. The open source model is well understood within the open source community, but not outside, and FRAND is an issue. If we conclude, then we can basically say that standards development or standard setting organizations and open source communities are creating complementary products, specifications, and implementations, and apply competing processes. And so they are partners when it comes to what they create, because they can work next to each other and they can complement each other really well. But they are competitors in the question of how should a technology be? How should the standardization process be driven? Should we go for an implementation first, or should we go for specification first, essentially? And this competition is, I think, the tension that we see primarily in the ICT sector, where many new, let's say, consortia of engaged businesses that are innovating in a certain field often choose to first collaborate on an open source project, develop the technology, and then think about specification. If you think of such an example, you're seeing that processes that used to be at standards development organizations are now originating at open source projects. So they're competitors. One question that we need to ask is, does this mean that everything will be open source in the future? And I think that's not the case. In our research, we have identified cost of change as the determining factor that basically influences whether going for specification first or for implementation first is the best approach. The higher your potential cost of change is, and also the more the cost of change happens downstream in the market, the more care it makes sense to invest into specifications to avoid this cost. A good example here are physical interface changes or recalls of cars. These are very important, very expensive. If you, on the other side, think of a software system that is openly developed under an open source license and is used in millions of devices around the world, and you find a small improvement in it, and you make a new release of the software, the cost of change here is very low. It is very low during development, and the deployment of this technology is potentially automatic and globally. So it is very easy to say, I can fix this if it's broken, or I can improve it if it needs improvement, and I don't need to recall the cars for that. And in this case, you would choose an implementation first process. And a very good example here is, of course, the Linux operating system, which is the most widely used operating system in the world. No specification of Linux exists. Linux integrates multiple changes per minute on average, and nobody could keep up with the specification. So you have these two examples, basically, high cost of change, hardware, for example, hardware interfaces, and then software, collaboratively developed software that has low cost of change. And then you would choose implementation first approaches for low cost of change and specification first approaches for high cost of change. Now, the tension between specification and implementation in the market, I think it is for the most part already resolved, but our institutions are struggling with the changes that I'm describing. So the European Patent Office, for example, says that specification is everything. Something that is not specified in a patent doesn't exist. Standardization organizations say implementation follows specification. You first need a specification before you can make an implementation that is conforming to it. Makes sense, but it's not how the market works. The open source point of view is implementation is everything. We only create specifications if they're beneficial. The code is the specification in a way. What we often see is that open source components are not just complementary to standards, but the default implementation. I will give an example a bit later where default implementation means that there's only one implementation. It is collaboratively developed by many players, and nobody would even think of making a second one because you can't compete with something that is free and developed by the best experts in the world. Okay, now I'm going to skip ahead a bit because, let me see. Yeah, so from a process perspective, there are some differences between the two camps that primarily influence who can participate in them. The open source community is very decentralized and has very low barriers to entry except technical expertise. So if you're able to participate from a technical perspective, you're welcome. You don't have to pay anything. You don't have to ask for permission. This is in contrast often to standards development organizations that are either based on national nominations or membership fees. And as a result, and this is something we're highlighting in our studies, small, medium-sized companies are more prone to participating in open source development. And large enterprises and well-established research organizations and others are more prone to participate in standards development. This is not just a question of the efficacy of the process, it is also a question of barriers to entry and cost. But this also means that openly governed open source communities can be a replacement for standards development processes. And this is something we're already seeing with the establishment of, for example, the Joint Development Foundation. I will talk about this in a minute. So the main issue here is the process incompatibility. One issue about that is that the decision about the process needs to be made very early in the process. So if you want to openly collaborate and you publish your implementations from the start, you can't take this back at some point later. So you can, for example, not apply standard essential patents to the technology if the technology is developed openly from the start. And that's a path decision. You make it early on, you can't change it. And since many industry consortia or technology communities prefer open implementation from the start, we are now faced with a lot of technologies that are implemented this way. Think of data center technologies, think of all the technology foundations for AI. They're all open source projects. They were not specified first, and some of them, including the technologies at the Cloud Native Computing Foundation, are for the most part still not specified today, even though they dominate data centers worldwide. Okay, there is, this is, for example, the Open Container Initiative. That's one part of the Cloud Native Computing Foundation. And their mission statement says, the Open Container Initiative is a lightweight open governance structure for the express purpose of creating open industry standards around container formats and runtime. This is the mission statement of an open source foundation. And this tells you a little bit already that open source foundations see themselves as actors with the same purpose as standardization working groups. Another example is the chart of the Cloud Native Computing Foundation that says the role of the Cloud Native Computing Foundation is to foster common technical standards. Now, the CNCF is one of our biggest foundations at the Linux Foundation, and it's exclusively focused on implementation. But their mission statement is to say, we are here to foster common technical standards. And they're very successful. And then the Linux Foundation also has a group called the Joint Development Foundation, which is a nonprofit organization that is essentially a standards organization in a box, where the governance framework for standards development working groups and projects is more or less predefined and can be established instantly, and operates under the open source community's umbrella. So examples for projects that are hosted there are GraphQL, Trust over IP, and Ultra Ethernet. And especially with Ultra Ethernet, you see that this is a standard that is very much the domain historically of a standards development organization. This is a hardware standard, essentially. So we see in practice this shift that open source foundations are adopting roles that the standards development organizations took in the past. Now, the Linux Foundation, and this is a caveat, is a trade association. This is a statement by the Software Freedom Law Center saying the Linux Foundation doesn't necessarily operate in the interests of the public good. Naturally, because we're a member-driven organization, we are operating in the industry in the interest of our members, who happen to be interested in healthy and well innovative open source projects. We do not have a special relationship with the state. We don't have a Staatsvertrag like Dean has with Germany. This is mostly, from my perspective, a historical development. We are not that old yet. But the more widely established stakeholder engagement that we would see in standards development is currently not the case in the open source community. Now, I would like to highlight two cases that we've discussed very recently that indicate kind of where the market is heading and what new observations we can make. The first case I would like to highlight is the Open Charge Point Protocol and Linux Foundation Everest. The Open Charge Point Protocol is a technical specification that describes technologies for electric vehicle charging. It was approved in 2024 as IEC 63584, meaning it's a recognized standard now, and it's being widely adopted all over the world. In the United States, it's mandated, and it's used in Korea. We assume it's used in China. It's adopted in Japan. It is not mandated in the EU. So of the different regions where a European developed technology is adopted, the EU is lacking. The counterpart to OCPP is Everest. This is the open source reference implementation to the Open Charge Point Protocol that was originally developed by Pionix in Germany and then donated to the Linux Foundation and is now developed at the Linux Foundation Energy Foundation, which is a collaborative project. It's Apache licensed, which means it has an explicit patent grant, sorry. It implements the full OCPP 201 standard, and it's becoming the national reference in the United States. So what you see here in this case is the default implementation. There is no other open source project that implements this standard at this level. And if you look at the actors who are participating as members in LF Energy, it's a global consortium. Like all regions are represented. And you have a formal standard promulgated through IEC and then adopted by Sensenelec, by the way. So there's a European transposition of the standard. And this is where the market is heading. There's one joint implementation of the standard developed by a global consortium and specified in a promulgated formal standard. So we have a parallel development of specification and implementation. We have the Open Charge Alliance, the Standards Development Organization. Here it's a consortium that is then formalized to the pass process at IEC, collaborating very closely with the Linux Foundation Energy Foundation. And we have governments interacting strategically with both the standards development process and the implementation at an open source foundation. The one region in the world that does not use open source adoption strategically is Europe. China and the United States are integrating open source technology adoption in their national technology strategies already. And the formal standardization here has two aspects that I would like to highlight. One is it's going global first. So the Open Charge Alliance has developed the specification and submitted it to IEC to then be translated back into a European standard. So global first, then European. And the other one is it's essentially industry-led, and the industry is collaborating on the implementation at the same time. So this is Open Charge Point Protocol and Everest, a very interesting case from my perspective. The second case I would like to highlight is RISC-V. RISC-V is an open instruction set architecture. It's essentially the description of how a computer processor works. It's developed at RISC-V International, which is headquartered in Switzerland. It has more than 4,500 member organizations from 70 countries. The specification itself is under an open source license and royalty-free. And you can already imagine how this changes the market. 10 years ago, when this was invented, people said, oh yeah, this is only going to be used for like low cost, low power processors. That's not the case anymore. We see very wide adoption of this chipset. The trade tension actually is beneficial to the adoption of open instruction sets. There were 40 specifications ratified in 2 years, and the RISC-V International Organization has been approved as an ISO/IEC pass submitter just recently. And this basically means that they're now able to continuously submit the instruction set architecture standards that RISC-V develops through IC to become global standards. And there is a lot of open source development going on, both for tooling, for chip design, and for actually shared actual chip designs. This is a member-driven organization where it works very much like an open source organization. Naturally, the technology area is more rigorous. Chip design is not something where you can try and error with collaborative approaches too much. But the participation is pretty open, and this really shows also how standards development can happen in the future. So basically what you see here is that an open source inspired, openly governed organization meets the highest formal standards requirements globally and is systematically and strategically adopted by regions across the world as a means of digital sovereignty. It also shows that openness can completely coexist with formal standardization as long as the standard that results is not patent encumbered. What we see as common patterns here is we combine open specifications with open implementations. The governance balances, I think, a little bit more openly formality and participation. So the access barriers to entry are lower, and the formal requirements are reduced, and more online collaboration is possible. And as a result, this is more convenient. Industry consortia, basically these open source foundations are industry consortia, essentially. They are performing functions that are prior provided by standards development organizations. Governments are increasingly recognizing this function and are supporting open source foundations and adopting them in their strategic plans. And you can have formal recognition. RISC-V is not the only example. Without sacrificing openness of the development process. And I think this very neatly highlights the future of standards development in a collaboration between the open source community and standards development organizations. And I would stop here and see if there are questions in the Q&A section that we can address. Thank you.
Yeah, thank you, Mirko. Thank you very much. To widen a little bit the view from traditional standardization now to another mode of standardization, that means the open source world. I do not see questions in the Q&A. And also not.
There's a hand.
Oh, there's a hand up, but I think you have to write the question in the chat, please, because you are not. I think we didn't give you the opportunity to speak or do it. Can I do that? Is that working? Let's see.
Yeah, we can wait a little.
Yeah. Now you can speak. You can speak now. Hussein Baskin, you can speak.
Okay, so I see 2 questions now. One is, what about standards?
Questions, yeah.
What about standards that are required, for instance, by EU law, like for medical device development? So this is a very interesting question because it combines a bit the perspective of how things are today and how things can be in the future. I did not go into the question of accessibility of standards in the EU. You may be aware of the Malamud case, which is essentially a court case that said if EU law references standards, that these standards need to be, they become part of EU law and need to be available to the affected citizens. It's unclear how this will play out. This is still ongoing. And my expectation is that we will end up in a situation where, at least in some form, any standard that the EU wants to mandate is publicly accessible. Now, everything I explained does not say that regulators cannot reference standards. In fact, it makes sense, especially, as you say, for medical device development, to have security standards and safety standards to mandate from a legal perspective. The technology development doesn't necessarily start from the standard, and that's a challenge for EU regulators, because they have a question of what they can reference. Like, how can they point to the technology and say, your implementation needs to follow this? I think the industry is approaching this primarily with the iterative approaches I have explained, where basically the implementation and the specification are going hand in hand. But one demand we have, and I think this is maybe less applicable to medical devices and more to digital devices and cloud technologies and things like that, is that we say that EU regulators should also be able to reference openly developed technologies and not just standards. Example, the Linux operating system is the most widely used operating system in the world and doesn't have a formal standard. And the EU regulators cannot say a device should run Linux, but they could. Standards will be required, especially if there's a regulatory push for it, and we will still have to develop specifications for those purposes. This doesn't mean that the technology development has to start with the specification. And I think this is maybe the answer to this.
There's another question in the chat, and there's one in the Q&A.
Well, I'm looking at the chat here mostly.
In the QA, there's a question, are there examples of open source projects that were so successful that they were later on translated into official standards?
Yes, there are. Primarily, for example, programming languages like ECMAScript, JavaScript. JavaScript was originally JavaScript is the most widely used programming language in the world, as far as I know. And it was originally developed as an extension to the Firefox browser or its predecessor, and became an ECMA standard over years. So there are multiple examples for that, but I would like to challenge the premise a little bit of the question. The premise is, if an open source project is really successful, then we need to translate into a formal standard. And the counter argument to that is Kubernetes. Kubernetes is one of the most successful standards for how you operate data centers. And it is very, very widely adopted. And it has not been translated into official standard because nobody needs that. So that's maybe the challenge we're looking at, is we need to motivate, where necessary, the need for specification, because the market actors involved don't necessarily require a specification to promulgate a technology. So the logic is not, if something is very successful, we need to specify it. The logic is we need specifications where they are useful, for example, to be referenced in regulation. Okay, that's that question.
And then maybe a concluding question here, what's the way forward for society, companies, and technology? From your perspective.
I purposely took out this part of the presentation because we only had 1 hour. Actually, Knut Blind and I worked on a futures of IPR foresight scenario. Maybe, Knut, we can reference that.
Oh, yeah. I put it in the link. Yeah, indeed.
Yeah, we can share that, because that's really there was a whole exercise, like a whole project, where we played out different scenarios and said, how could this evolve in the future? And a lot of what I presented here today is actually written up there. So I would suggest you look at that. But from my perspective, for society, we're already seeing a beneficial situation, because we have 2 complementary approaches to the development of technologies and their promulgation that are competing with each other for efficiency, and that improves the market overall. For companies, the environment becomes more competitive, and I think we need to realize one thing, and that is that especially in the EU, we're behind on strategically shaping our internal market according to what I have described, behind in the sense that other regions have started earlier than we did. For technology, what I'm describing here is not new. This is not the future of technology. It's the present and the last 10 years. This has already happened. In maybe one caveat, I speak primarily of software and software close to software innovation. The market already works like this, and the market is coping very well with that. This is not a scare scenario for the future. This is happening today. And with that, we're at 10 o'clock.
Yeah, thank you, Mirko, very much. Thanks for also all the participants for attending the 5th webinar. We will see each other next Thursday again at 9 o'clock. Who is interested, and there will be also probably a replication of the whole series in 26, but I will let you know. Thank you very much. And I stop here.
Thanks, everybody.